Our first question now is find an expression for dy dx in terms of t for the parametric equation x equals to e 2t and y equals 3t squared plus 1. So these are the two parametric equations we have, and we need to differentiate them with respect to x and then do an algebraic manipulation that would give us dy dx. So for the first one here, we should say let u be equal to 2t, which then implies that we've got x being equal to e to the power of u. Okay, so what we are going to do in this case now is to find dx du, okay, which then just gives us eu. Okay, we'll keep that. And then for this u function of t, we are going to find du dt, okay, which then gives us 2. And we know that in order to get dx dt here, dx dt, we need to multiply dx du times du dt, because these components, we now have them. This is our du dt and this is our dx dt, because here the du's are going to cancel, which is a common practice on parametric equations. So now what we are going to have is eu. Now eu dot 2, and then when we do this we get 2 eu. Now we need to remember that in this case u is equal to 2t, so the derivative of this is 2e 2t, which is our dx dt. So we are going to keep this, and then we do the derivative of this. So now for this second parametric equation, we know that dy dx is equal to 6t. Now again here, what we have is dy dt, sorry. Now dy dt, dx dt, we need to do something so that these two can give us dy dx. Now our dy, in order to get dy dx, we need to have a product of dy dt times dt dx. Okay, quite similar to what we did here, but then in this case our dt's are going to cancel. But the key thing here now is that we do not have dt dx. What we have is dx dt, so we need to flip this fraction. So in order to now finally get our dy dx, what we need to do now is to multiply dy dt, which is 60 times, but remember dt dx is the reciprocal of dx dt, so we're now going to multiply this by 1 over 2e 2t, like that. Okay, if we do that now, we're going to get a situation of dy dx being equal to 60 over 2e 2t. Okay, now if we think about this, if we simplify this, we should be able to cancel that and that and just get a final answer of dy dx as being equal to t over e 2t. So this is the answer for the dy dx here. And the key things are these algebraic manipulations where we are trying to get a product of dy dx. So this is for 1a. Let us look at 1b. The graph of y against x passes through the point 1, 1. Find the value of t at the point 1, 1. So they want us to find the value of t at the point P. Now to do this, it's very easy because we've got an equation in terms of t which is given as x equals e 2t, and then we do have another equation given as y equals 3t squared plus 1. So what we are going to do, since this point gives us x and y, what we have now is, if we substitute x here, it means we've got 1 is equal to e2t. And then here, if we substitute y, it means we've got 1 is equal to 3t squared plus 1. Now, if we look at this, it means where there's 1, we can put e2t. Okay, so in this case now, to do this, we are going to say, here, we can actually do, it's very easy, you can do it two ways. You can replace here, or actually just solve for t from this equation because it's easy. So we can have 1 equals 3t squared plus 1. And then if we transpose this, we get 3t squared equals to 0, which then implies that t is equal to 0 at p being equal to 1, 1. So that's the value of t at 1, 1. And then they say find the gradient at the point P. Now, gradient is simply a dy dx at a given point. And we already have dy dx here. We found that for number B, we found that dy dx is equal to t over e2t. Okay. Now they are saying at this point here, P. Now at P, we know that t is equal to 0. So now it implies that at this point, our dy dx, okay, our dy dx is simply going to be equal to 0 over e to the power of 0, because if I multiply 2 times t, which is 0, it will give me 0. Now, anything into 0 is 0. So it implies that our dy dx at the point t, p equals 1, 1, is 0. Okay, and if you think about it, if it is 0, it means this is a stationary point actually, because dy dx is equal to 0 at the stationary point or at the turning point, which is what actually part 3 is asking us. What does the value of the gradient tell you about P? If dy dx is 0, it means the curve is turning. So now we are going just to say it means the point P is the turning point of this curve. So this is how we answer this one question here on parametric equations. So let us now look at another question that we may see that may be interesting. Maybe this one, if we want to. Let's see. Yeah, so we can actually try to answer this one here. Okay, so this is question number 2. And they are saying a crane swings a wrecking ball along a 2-dimensional path defined by parametric equations. X equals to that, 12t, and y equals to this equation given here, which is 9t squared minus 9t plus 4, where t is between 0 and 1 as shown here. So you've got this wrecking ball that is swinging more like a pendulum. Now, in this case, we need to know that y is actually talking about the height of this wrecking ball, and then this is just x, the distance it is covering along x, or the horizontal axis. So now x and y are respectively the horizontal and vertical displacement in meters from O. O is here, the origin, and this is where they are going to release the ball from here. Okay, and t is the time in seconds. So now this is a typical example of a pendulum in physics, and yeah, but just that it is put on the x or y plane. Okay, now point A indicates the initial position of the wrecking ball at time t. Okay, find the height of the wrecking ball after 0.3 seconds. So we need to find the height of the wrecking ball after 0.3 seconds. Now this, it gets released at t equals to 0. Now we want to know how high it goes along the y after 0.3 seconds. So this one is basically just getting the y equation that is given, and where there is t, we put 0.3. So you do 9, then 0.3 squared minus 9, then 0.3 plus 4. Then whatever the answer this will give, that would be the height of the ball after 0.3 seconds. So you can use your calculator there. Let me use my calculator here and see what we are going to get there. So we've got 0.3 squared. Okay. 0.3 squared. Okay. Then minus 9. Okay. Plus 4. So this one, according to my calculator, it gives me 2.11 meters. So it means after 3 seconds, this ball will be at a height of 2.11 meters. That's our A there. Okay, then B, find the minimum height of the raking ball during its height. The word here is minimum, and you know that to find the minimum or maximum point of a curve, that is just like dy dx equals to 0, because you are trying to find the turning point of a curve. So the curve gets to attain its minimum or maximum point at the turning points. So here they are just now asking us to find dy dx, and then equating it to 0 to find t. And then once we find t, that t value, we're going to replace it onto the y. That is what this question is asking us. So what I'm going to do now is to start working out b, but let me first copy the x equals 12t, because that's what we have, and we've got y equals 9t squared. 9t squared minus 9t, so we've got 9t here plus 4. So to find the minimum height of the raking ball, we need to find our dy dx using these two parametric equations. So first we need to find dx dt, which is very easy. Here you get 12, and then here we need to find our dy dt, which is now going to give us 18t minus 9. Now we know that to find dy dx, we need to multiply dy dt times dt dx, so that these can cancel. But dt dx is the reciprocal of 12, which is just 1 over 12. So this implies that our dy dx is simply going to be equal to 18t minus 9 times, so I'll put over 1 here, times 1 over 12, which then gives us, so let me draw a line here, which then gives us dy dx being equal to 18t minus 9 over 12. So now this is the point, this is the general form of the turning point, where it can either be maximum or minimum. Now since the question states to say find the minimum, we already know that this would give us the minimum time at which this ball is going to have its least height. So now here we need to solve for 18t minus 9 over 12 equals to 0, because it's a turning point. We'll cross multiply here to mean 18t minus 9 equals to 0, since 12 times 0 is 0. Then we just solve for t here. You can confirm I'm just trying to do, so this is 9 over 18, and then meaning t is equal to half, which is t equals 0.5. So now this is the time when the raking ball is at its minimum point. But the question says find the minimum height. Remember that height is given in terms of, or along the y-axis. So now since we know the time at which it's at its minimum height, we are going to get the y equation and replace 0.5 where there is t, in order for us to get the minimum height. And then that should be very simple. I'll write here y should be equal to 9 times 0.5 squared minus 9, then 0.5 plus 4. So what we just need now is to use our calculator again here and see what we are going to get. So that's 0.5 So the answer that I'm getting is that the y would be 1.75 meters. So the minimum height of this wrecking ball after 0.5 seconds is 1.75. That's the answer to B. The key thing was knowing when they say minimum height, the minimum or the maximum of a curve is found at the turning point. So this one was a very good question as well. And just applying parametric equations there. And then there's part C where they are saying find the horizontal distances from point A at the times when the wrecking ball is at a height of 2.9 meters, giving your answer is accurate to 1 decimal place. Okay, so now if you look at the diagram that we have, we're actually working with the height in y. Okay, now here the question they're saying find the horizontal distances, because this ball is making a sort of a curve when the height is at 2.9. So let's say the 2.9 is here, that line, 2.9. They're asking now for the horizontal distances, which means this value here and this value here, because this is a curve it is making. So in other words, it's more like they are asking you to say find the values of x when y is 2.9. So we know that since this is a curve and this horizontal line is going to cut the curve at 2 points, that's what we are trying to find here. So the first thing to do here is actually very simple, is to say let me find t when y is 2.9. So you already have an equation which is y equals 9t squared minus 9t plus 4. So what we just going to put here is 2.9 and then solving this. So you're going to have 9t squared minus 9t plus 4 equals to 2.9. And if we try to solve this by taking the 2.9 here, I think we are going to get 9t squared minus 9t, then we get plus 1.1 if I'm not mistaken. I tried to work through this. Now we've got a quadratic equation here, and we just need to solve for t here and see the values of t when it's at 2.9 there and there. So we solve using a quadratic equation, which I haven't put here. The same quadratic equation which we can now give in terms of t here, to say t is equal to negative b plus or minus b squared minus 4ac over 2a. This is what we are going to pick. We've got our a, we've got our b, and we've got our c. Now if you do that, I think your values of x that you are going to get, I copied them here. You are going to get two possible values of t. One of them is t equals 0.143 seconds, and then the other one that you are going to get in that equation would be 0.857 seconds. So when the height is at 2.9, the time would either be 0.143 seconds, or at this point it would be 0.85 seconds. So now, since they are asking for the horizontal distance, which is distance along the x, okay, and we already know the times, what we now need to use here, just as we were finding the height along the y using the y equation, here we are going to use the x equation, which is given as x equals to 12t, and your duty is to replace this t here where there is t, and then that other t there. So I actually worked it in advance here, because x is equal to 12t. We are going to put to replace this t with the time that we found here to find 1.7, and then the other t there in the same x equation to find 10.3 meters. So these are the answers, and I just wanted to give you a quick look at most of these answers, which I'm sure you should find very nice and maybe easy. So this is about question number